Alright, welcome back to the data sharing channel. Today we're going to look at this paper by Matt Kernan and myself on investigating energetics ordering of stable and metastable TiO2 polymorphs using DFT plus U and hybrid functionals. So if I look at the paper here, the gist of this is in material science, titanium dioxide, TiO2, can exist in several different crystal structures: rutile, anatase, brookite. And rutile and anatase in particular are very close in energy. And so it's difficult to say which one is more stable. And when we try to calculate that with DFT, it turns out that some functionals say anatase is stable, others say rutile is stable. And as you change the different levels of theory, that's what DFT plus U and hybrid functionals are, you just find out they switch around on what's more stable. And so this whole paper was really investigating that, to look at these differences in energy for anatase, columbite, brookite, etc., using DFT plus U and using a hybrid functional where you get to specify an alpha. And this all resulted in quite a lot of DFT calculations for us to be able to look at it. So let's just scroll through here and see what, I'm not going to go through all of these, but we have PBE0, HSEO6, as hybrid functionals. We had a handful of polymorphs, a bunch of different pseudopotentials, different ways of using U. And let's see if we can get down to, a figure like this. So each of these data points would represent a calculation for different functionals, for different pseudopotentials. Here's another one, using different pseudopotentials or same pseudopotentials, different functionals, etc. Then we have a whole section on exchange correlation functionals, and some tables and things like that. Okay, but like with other videos here, I really want to get to what did we save when the supporting information and how can we go about using it. So Matt Kernan was an excellent student and very skilled at using databases, and so he opted to use a database to store all of this in, and specifically he chose SQLite. And SQLite is nice. It's a file-based database, no server required, and you might recognize this kind of LaTeX outlook. This is an output from org mode, and as we scroll down here, you see these thumbtacks that indicate that we have attached the data to this particular PDF. So here is, this one indicates that it is the source, so you can get the plain text source. And then as you scroll down, here we talk about the SQLite, why we chose it. This is a relational database that he spent a lot of time putting together. And there's all these details in here, 188 pages of how this data is stored in a database, what the relations are, and then in subsequent sections, the individual tables. And we go through quite a few pages of these. I won't go through all of it, but then we get to a section on reproducing the data. So we have a couple of things going on. It looks like there is an actual database stored that we're going to be able to extract. And then there are a bunch of CSV files and directions for how to construct that SQLite file. So we're going to open this in a little bit. This is just Python code that opens the SQLite database, creates a table, reads a CSV file, and inserts that data. And there is one for each of these tables. I think we're probably not going to try to just recreate this. We'll first see if we can use the attached SQLite database and maybe reproduce this calculation input file. So here's the idea. You'll open this SQLite database here, and then we will execute this query. This is quite a long query, but it allows you to be very precise in what you want. And this is better than the JSON example I showed you before. With the JSON example before, it was pretty convenient, but it also wasn't a very deep, I think there were like 5 things. You could have the the oxide, the polymorph, the exchange correlation functional, whether it was an equation of state or a final calculation, and you had to index it in that order very precisely. Here we can change the order of these, and you can see we have a much richer ability. This is much more sophisticated data than we had in the other one. Like, it wouldn't be easy to find all the calculations at a specific end cut in that previous example. Okay, so let's get to work. So here I'm going to just open the folder. I already downloaded that. This is the PDF file, and I opened it in here so that you can see. It's not very easy to see probably in this little window, but all of these attachments are here, and you can individually open and save these where you want, but we're going to instead we're going to use a shell command, and the shell command is based on PDFTK. So here, let's change into videos 4. And PDFTK, you can find it, the website for it is just a command line tool that will allow me, here, why don't I just copy this? It will extract all of those CSV files. All right, so we have here all the CSV files. This is the SQLite database that we should be able to reproduce things, and also you see now we have this supporting information.org file, and so I'm going to switch now to that. All right, so now we're going to be reading the actual file that generated the PDF. It's a big file, so it probably takes a while to load and whatnot. And while that's going, let's go to maybe our table of contents, and let's see if we can reproduce some calculation input files. So let's go to this one. All right, so we're going to look for this. I think here it's even easier. Reproducing the database, reproducing its input files. Here's an example. So let's just have a look here and see. It might be possible to even run this verbatim. It looks like it is, this is old Python 2. Okay. So let's see if we can modify this a little bit. So this was 2014. Obviously, you can see from these print statements we had not switched to Python 3 yet. So we're still looking at old Python 2 code. And it's usually straightforward. There are utilities that will automatically do this kind of stuff, but I usually prefer to do it one at a time, especially for just print statements, because then I have a better idea of what I've done. All right, so those are the obvious ones. Let me just run it and see what happens. So we're missing, oh, I missed one. All right. So on the right, we have the original version. On the left, we have the updated version. And you can see these all match what is over here. And so just by extracting that SQLite file that is right here, we're able to pull out exactly the same data that we had from before. And that probably means that we can then go to over here, and let's see if there's some figure generator in here. It is interesting, you know, if you look here at some of the stuff that Matt wrote into these, He spent a lot of time. This is called relational algebra. If you're familiar with it, then it means a lot. This is the mathematical expression that he's using for the query. And then I like to think of this as the advertised intention. And then the code is what you actually did. And so that's important because the code does what it does. And you don't know necessarily what the person's intention was because maybe they made a typo. And so it's nice to declare in narrative text what is your intention, what is the goal, how do you go about it, and then have the code, which is what you actually did. So here this code's just going to open the database. It creates some containers. It does a query. Then it attaches, updates those things, and then it goes through this list. Looks kind of complicated. It's going to print a bunch of stuff, and then it's going to make a couple of figures it looks like. So let's look at this one. This one will also require some Python 2 updates. And I'm going to just come over here. I'm going to switch from Python to Jupyter Python. And that's going to let me, I'm just going to comment these lines out, but we should still see the figures pop up. Maybe we'll just look at the figures. I don't know. Maybe it won't take long. If I was way more wizardly with Emacs, I would have some macro or something that would automatically do this, but I never remember all the nuances of doing that, and in the end it doesn't take me very long to do this, even though I concede it is probably annoying to watch and it is a little annoying to do. And I'm only doing this for being able to compare the actual outputs for checking reproducibility from what we previously did and what I'm doing now. While I do this, I'll say that it would be pretty challenging to figure out another way to represent this data that allows us to write code like this with a query and be able to do the kinds of things that I'm doing. It's not impossible. Let me run this and see if it works. Probably if it was a giant Excel sheet, it might work. But it wouldn't give you the ease of searching. Let's see. Dictionary has no attribute sort. All right. That is some new thing. Let's see. This is also a Python 2, Python 3 thing. I believe keys is actually a dictionary, so I bet if I do this. There we have a figure. Now let's see, is this just to make one figure? I think that's right. It makes one figure with all of these plots and all of these labels, and this is one of the figures that is in the original paper. So I'm not going to do them all. There's a lot of figures, but with just this small kind of test, it seems pretty likely that we will be able to reproduce all of the results that are in the supporting information. And if you are interested in SQLite, you can learn a lot by how Matt set this up and why we have all these inner joins. Basically, this is making a big Excel sheet and then filtering out the rows for the things that you want, and then selecting various quantities from each row. So maybe you could imagine this happening in pandas or something like that. But SQLite is a tried and true database format used on millions of cell phones and millions of mobile apps. It's extremely robust. It's extremely performant. And as you can see, This is a 10-year-old SQLite file that we are simply using, and everything seems to be working perfectly fine. So this is this paper. We haven't used any approach like this, since then. It takes quite a bit of expertise to construct and then use and then write it. The supporting information is probably like 10 times longer than the actual paper. But this kind of thing is why I don't think that it makes sense to have a standard for data, because everybody has different kinds of data and wants to do different kinds of things with it. And so it just doesn't make sense to try to cram all forms of data into one format, JSON or XML or CSV. You have somebody might have images that they want to have in a database. You may need other forms, and like ultimately this data could be and is stored in CSV files. But the CSV files themselves are not actually easy to use. You need to combine this with several other files to construct all of these different graphs. And I don't know. Let's see what's in structure. This just has the polymorphs and symmetry, and looks like row IDs, and then there's different parameters. So like the raw data here is saved, but this data by itself isn't as useful as the other SQLite database combined with the code that says here's what we're doing, here's how we do it, and here's the result that we got. So I think overall this is another paper that gets a high grade in my book for data sharing. You do have to spend some time reading the paper and gaining some skills. It actually took me like half an hour to get PDFTK working on my Mac so that we could do that simple extraction. And but all of those are kind of features of data sharing and getting the data from a paper or from a Figshare or somewhere else, and then using it for something practical of your own. So I think this will probably be the last paper for a while that I focus on this attachment idea, because there's plenty of examples from my group where the data is simply too large to attach to a PDF. Even these are all fairly small, maybe, I don't know, let's see, maybe a few megabytes. 5 megabytes is a trivial amount of data to embed in a PDF. But if it was 5 gigabytes, then you don't want a 5 gigabyte PDF. You want that data somewhere else. And in the future, we'll look at some examples where we have tried to put gigabytes or hundreds of megabytes on Figshare or Zenodo to see how they work. Okay, so let's go back to here. Let's add some notes. We used SQLite to store and retrieve data. The original SQLite and those are the main notes for this one. That SQLite was the right answer for this particular paper, and we were able to save the data and the code in the SI, and then reuse. This was still Python 2. So we still needed some light modification. I think it's worth noting I used PDF PDFTK to extract the attachments. I didn't show you this, but I actually spent like half an hour trying to get other Python PDF packages like PyPDF2, PyPDF, PyMuPDF to extract those attachments, and none of those worked. None of them could see any attachments, and I don't know why, but PDFTK worked fine. And of course you could fall back here and manually extract each one. I just felt like there were too many of those to do. And I remember using PDFTK many years ago, and it was just a one-line command to look up. So that's a downside. Who knows 10 years from now if there will be a PDF reader. I mean, you can check what's in the PDF, and actually let's try that just for fun. This is going to open this in Emacs, and then I think I can make it show me like the raw code. And so this is what raw PDF code looks like. It starts out %PDF 1.5. A lot of this is like binary byte stuff that isn't that useful. I don't know what I'm looking for, but I'll see it I'll know it when I see it. This is what gets parsed by PDF readers anyway. Actually, what I am looking for is to see if there is plain text CSV in here somewhere. Oh, that's only 2%. Let's go a little faster. So here is the annotates. So this is an indication that there is some annotated file that's embedded in here, but it's not obvious we're going to see. This just says binary file matches. So even if there's not Adobe Acrobat in the future, there should still be some ways, if it's valuable enough, to read this PDF. I suppose this is the same issue with, like, is Figshare going to be here 20 years from now? I don't know. Cost somebody money to run it, and they might run out of money. All right, so this is not as useful as I hoped. But maybe I'll try one more thing and try going to the end. So we have lots of these annotations, but it's not obvious how you read them. So that's what you need the reader for. All right, so I'm going to close this and wrap this video up. Maybe we'll end. All right, so I need to copy. Probably thinking I'm going to give all of my papers A's. but this one I didn't give an A, and there are some other examples that aren't quite as good as I might like. And papers that are older than these, none of them get A's because probably there's no data stored at all, or it's stored in some terrible format like a PDF table. That's just not good at all. Okay, so maybe one more thing, just to finish off, I will just go ahead and upload this stuff to GitHub. We have some untracked files. I can stage this. I think I'll just put everything there. Stage, commit, updates. This is Majit. And I'll go ahead and push it now. And I'll have a few more updates when I add a video link after this. But you can now go to the website and find where it is. So if I go to GitHub here, you can see it's already been updated for video 4. And we have this new information here, and I'll add video 4 once I get the link for it. Okay, so I love SQLite. I use it a lot. We don't use it super often for saving data. It has to be a very specific need for highly structured relational data, and that is not a common. It's not very common, and there are often other simpler ways that are simpler but less powerful, but get the job done. So thanks for coming, and